So yeah, hi, I'm Nick Sharp, and I'm joined by Jenny, and this is an Infineon and Edge Impulse workshop, and we're going to be showing you how to do an acoustic classification using Edge Impulse and a PSoC 6 device. We did put up on the website that there was a few prerequisites for this, which is to download Modus Toolbox 2.4 and to also purchase the 062 prototyping kit. It's a PSoC 6 device. So if you don't have those, that's fine. You can just follow along and see what's possible. But if you do have those, perfect. We can go ahead and get started. So let's go into. Oh, come on. There we go. So first up, this was not specified in the prerequisites, but it is an Edge Impulse event. So we are assuming that everyone has already made an Edge Impulse account with a new project. So, no data in there or anything. And then also that the Edge Impulse CLI is already installed as well. And the Edge Impulse CLI does require Python 3 and Node.js, and you can simply run this from your command line, and you will install the Edge Impulse CLI. Jenny just posted the link to the installation guide for the CLI in the chat. So if you don't have this, go ahead and do this now as I move through the slides. It's pretty easy, shouldn't have any issues. And if you do, you can ask questions in the chat. The other item is this is going to be a classification, acoustic classification, and we're going to classify whether water is being poured into a cup or not. So if you can, go grab 2 cups real quick and just fill one with water. And we're going to use that to collect data and to also verify our model later. And if you have those things, we're all set to go. So a few slides to go through, and then we'll get into actually building a model, training it, and validating it on the device. So the agenda is kind of going through Infineon's Modus Toolbox ecosystem, and then we're going to kind of discuss Modus Toolbox with Edge Impulse, and then get into the workshop, which is the acoustic event classification, using those 2 items. So it should be pretty straightforward. So first up, Modus Toolbox. What is this? So Infineon supplies Modus Toolbox. This is our toolkit. And we don't like to call this an IDE, mostly because it actually wraps around different IDEs. You can use IAR, you can use Visual Studio, or you can actually use Eclipse. And Eclipse is what comes native with the install of Modus Toolbox. So that's what we're going to be using today. But if you have any, later down the line, you want to use IAR or you want to use Visual Studios, you can go see the user guide, which is where this install is located. So you can go pull that up and see. But for right now, we're just going to use the Eclipse-based version. So what is Modus Toolbox? It's a collection of tools that helps you develop your project. So you can kind of see here, Modus Toolbox is a collection of tools, applications, middleware, and BSP is board support package. So tools really to help you develop. You can bring in different projects. You can use your library manager to bring in different BSPs, middleware. It's all inside of the Eclipse IDE, which is how we set up Modus Toolbox. We have different applications, so code examples and reference design. And the code examples are really, we send a lot of people this, to get started. If you need help with, setting up a SPI or a timer or counter, or even Wi-Fi, setting up your Wi-Fi module and getting it to run, our code examples are a great place to start and really just get you running quickly on those different modules. We also supply middleware, so we try to abstract some of the hardware here and make it really easy to set up, anything from graphics to security to Wi-Fi, and give you a library that really makes it simple to set this up. And our board support packages, we actually set up quite a bit of items around. You can see, on the board that we had to pick up, the 062 S2, we have an IMU on that. We have a way to read flash. We have just a couple different sensors on there. And so the board support package actually knows what different sensors or peripherals that you have and allows you to use those for that specific device. All this information is available at Infineon.com. You can go download anything that you need. We did post in the chat this slide deck. So you can see here that we have links to everything that you would need, for after. You shouldn't really need this right now, but you can go, check out our software and tools. We have an Infineon GitHub repository that you can go look through. And we have all our code examples, libraries, middleware, BSPs, anything you would ever need is there. But you can also use the project creator or our library manager to go pull those directly from Eclipse and our Modus Toolbox. So you can kind of pull them from different locations. We also have training repositories. So if you're running into any issues, you can go take some trainings. And then we also have our community forum, which is really nice. You can ask questions to any expert from Infineon, depending on the topic, and they'll be able to answer that for you and hopefully get your debugging, going the right way. We also have some links to our different driver libraries, depending on which device you want to use. Modus Toolbox does support PSoC 6, PSoC Fork, and XMC. And then we also have code examples for each of these as well. And I'll show you how to import those code examples. The workshop today will be using the Edge Impulse code example. So I'll show you how to pull that in so that later you can pull in any code example you need for any of your devices. So now kind of getting into the Edge Impulse plus Modus Toolbox. So typically the out of the box code example for Edge Impulse actually uses a different device and a different shield, but they're a little pricey and we wanted this to be a little more accessible to everyone. So we actually picked a different kit, and it's the one that we put on the prerequisites. So there are some things that we will have to change just because it doesn't have the same sensors as our 028 Sense shield that you see here. But the sensor interfaces with PSoC 6, and then the code example allows you to stream data straight to Edge Impulse's cloud infrastructure. So you can use that data and stream it in for training, doing any of your validation, any of your code example testing. And it makes it really easy so you don't have to go import data. We are going to import some data today, just because I've collected some ahead of time, so we don't have to spend a ton of time just continuously collecting us pouring water into a cup. Then the code example also supports down here, you can see Edge Impulse, Edge classification. So once we're done, we'll actually switch over what the code example is doing and be able to do a live classification on our device. And you can see that when you pour some water into a cup, it'll classify that we are pouring that water. And then when you stop, it'll say, we'll have some background noise, but that's about it. So the code example does make this really easy. Here, next up, we kind of have just a quick slide on, how you can balance your cloud and edge workloads. We have kind of 3 different models, and we'll be more focusing on the middle one today, but you can do with PSoC 6, you can do completely cloud-based where you're just sending data from your device, your sensor data from your device to the cloud over an MQTT broker, and then run an inference on the cloud. Then what we're going to be focusing on today is we're going to train a model in the cloud with Edge Impulse, and then we're going to deploy that onto our device. And then the sensors data will just be fed to that inference engine, and we'll be able to get a classification. The last one is the hybrid-based machine learning, where you can actually deploy on your device and then continue to send data to the cloud to continue training a model, and then redeploy a newly trained model if you see some performance gain there. So just kind of, options out there for the PSoC 6 device and what you can kind of do with it. And second to last slide, I promise. So the architecture and secure connected product with machine learning. So this is just a little more on machine learning. We're going to be focusing on the unsecured, but PSoC 6 does support a M0 plus secured processing environment that you do have a trusted firmware framework, and we do supply secure peripheral driver library that you can use in there. So if you're doing, something with the cloud or something where you need security, we do offer a course specifically for that. Today, we're focusing just on the machine learning piece. And so we'll do everything on the Cortex M4 to do the non-processing or non-secured processing environment. But it is important to know this is out there. You do have a dual core device if you went and picked up this correct kit. And yeah. So now requirements, we've already kind of talked about this. Obtain a PSoC 6 Wi-Fi Bluetooth prototyping kit, which you can see down here in the left corner. Once again, this is not the fully supported kit that the Edge Impulse code example runs with. So there will be some minor changes to the code that we'll make to get this to run, but we just really wanted to make it available. And this is one of our cheapest kits. Second is install Modus Toolbox from Infineon.com. This is a prerequisite. You can go ahead and do it now if you haven't, but this might take a few minutes. And then have 2 cups, one filled with water, as it is a water pouring classification. So now that we kind of have, some info out of the way, we can get into the fun stuff and actually show how to, train a model, set up the code example and everything like that. So what we're going to do is open Modus Toolbox 2.4 specifically. And you can see here, it's going to ask you for a workspace. I always recommend starting with a fresh workspace. And you can see here, I like to just put it in the C drive and keep your path length pretty minimum, just so it's easy to find everything. But this shouldn't matter too much. Put it wherever you want. And then once you have that path set, it'll create a workspace in that location, and you can just hit launch. Give it a second for this to pop up. So this is what a fresh project, we're going to have pretty much nothing happening so far. We actually need to bring in the code example. So you can see we have this nice quick panel, new application. And so I'll try to move slowly through this, and there'll be some times when code is building so that we can answer some questions, and I'll let people know they can post in the chat and we'll try to get to them. So under quick panel, we're going to do new application. And this is all linked to GitHub, so that's actually where we're pulling everything from. And you don't actually have to use the new application if you pull from GitHub, but it does make it the easiest way to do this. So first up, you're going to choose your board support package. As we were using the wrong kit, we're actually going to select the wrong kit. This is, if you're following along, make sure you select the CY8C kit 062S2. And I'm going to show you actually how to use our library manager to switch over to a different kit. So you can actually port a project from one device to another. Which is actually pretty useful. Say you're developing and there's a peripheral you need on a different device. It's pretty easy to switch kits for us. So once you select this, I repeat, CY8C kit 062S2 43012. I'm hoping the font's not showing up too bad. You're going to select this and you're going to hit next. So now we've selected a BSP. And then under machine learning, you'll see we have an edge impulse continuous motion recognition. And this is really just a great way to get started. But how I was talking earlier, we do have tons of code examples. So you can see if we go under peripherals, we have code examples for just about everything, every single peripheral, ADCs, timers, I2C, GPIO. We have things specific for Wi-Fi voice sensing. But we are sticking with the machine learning edge impulse code example for today. So you're going to click this and then you're going to create. So just back again, the CY8C kit 062S2 43012. You're going to hit next, and then you're going to select the edge impulse motion recognition. You're going to select that and click create. I actually already have this up, so I don't need to wait for that to build. And this is what it's going to look like when you first get this to build. This may take a couple minutes for you. So if you have any issues already, I'm hoping not. We just got into it. Post it in the chat and we'll hopefully get to it. But yeah, once you build it, this is what shows up. We have a README kind of walking you through the basic code example. If you use the correct or you use the fully supported device that we're not using right now, it's a little confusing and I'm sorry, then you do have access to a IMU, a barometer, and dual PDM mics. Today with the device, we're only using the dual PDM mics, but then we also have some options in here. So you can go see, we have a quick start guide for the edge impulse for getting started on a PSoC 6 device and how this kind of all works. So if you need extra information, this is a great place to go. This is information on using the code example. So if I'm not around, after this, you can, of course, go here and get some good information. I'm hoping everyone's project is now built by this time. So now we have built for the wrong BSP just because that is what was supported. And now I'm going to show you how to use our library manager to actually change what BSP and what device you actually want to use. So you can go ahead and open the library manager. This may take a second. And so in here, I'm going to just select this quickly. You can actually go and select, You can go and select different BSPs like we have now. I've already selected the correct one. When you come into this, yours will look like it'll have this selected and we'll have that deselected. You're going to want to go ahead and select the CY8C Proto 624343W, and you're going to want to deselect this kit. So when you run this, it should look like this. You're going to want to select the CY8C Proto 624343W, and then you're just going to hit update. And that's just going to bring in all the files for the new kit. So we're actually just going to change which device we're using real quick. And the nice thing about the library manager, though, is you can change BSPs. We also, if you go under libraries, You can pick anything, you know, support different shields, different sensors. We also have all our middleware in there, and you can also select different release versions. So if you need to update, you can do that all easily here. Or if actually you want to go to a previous version that was released, you can do the same thing and select you know, a previous version of that and import or get rid of any libraries that you do or don't need. So this tool really makes it easy to change anything in your project or get support for something in your project that you currently do not have. And we'll just kind of let this finish up. Is anyone having any issues so far? Any questions? And we will have time, about 10 minutes at the end, for general questions. So general questions, maybe wait till the end, but for, you know, any issues as you're doing this, please bring them up and we'll try to get to them. Goes extra slow when I'm sharing my screen. It's just sucking resources. Okay, so now we're good to go. We brought in the new BSP, got rid of the old one, and we can actually go close this out. And now what you're going to want to do is go into your terminal and make sure that you've pulled in all your correct libraries. You're just going to run make gitlibs. That's make space GETLIBS. And that's going to pretty much make sure that when you brought that BSP in, if there's any other libraries that require that BSP, they're going to rebuild those and make sure that everything is now pointing to that BSP, which will then make us, you know, pretty much good to go. There's some few other changes that we're going to make, and then we can, you know, really get into the Edge Impulse side. So once you've done that, it's make gitlibs in the terminal. Down below, we have console, problems, memory, and terminal. You're just going to run make gitlibs in the terminal. And then we'll let this load. Yeah, so I see a question that there will be an on-demand video later, and that's correct. We are recording this and we'll put this up. I believe it's going to be on YouTube. So you'll be able to follow along later. And there is also documentation that Infineon and Impulse have supplied to make this, you know, so you can go see this later and you should be able to follow all the instructions. So if you don't have stuff now, that's totally fine. This will all be available. This moves really slowly when we when I'm sharing. So hopefully this will pick up here and we can be done. So there we go. So now we've run make gitlibs. All our libraries have now been updated. We are now going to support the new 062 device. The last thing you have to do is change in your makefile, which is just found at the bottom here. You can see we have a makefile, and once you open that makefile, you'll see target on line 37. If you can't see lines, you can simply right click here and show your line numbers. So line 37, it'll actually have the old target. Change this to the CY8C Proto-062 4343W, and we should be good to go with the new kit. The only other changes we have to make is because we don't actually have a IMU or a the barometer. But this is how easy it is to change over to a new device if you need to. So now, hoping everyone has made this change in your makefile, just change this target to this CY8C Proto-062 4343W. I'm trying to move a little slow, so hopefully everyone can keep up. Next up, we need to fix the, it's kind of a funny fix. On this device, we do not have 3 LEDs. So we will actually need to change under source. It's EI device PSoC 62. And we'll have to set all our different BSP LEDs to the same pin. This is relatively easy. I will actually put this in the chat for everyone. Let's copy that and paste it into EI device PSoC 6, the C++ application, not the .h, and that's found under the source folder in your project. So pretty easy. 2 more changes, and then we'll get into Edge Impulse. Sorry about all this. This one is also the IMU we do not have on this device. So you're going to want to, when you come into here, it'll actually have all these set to different BSPs, and you're just going to change them all to pin 0. I'm also posting that in chat so you can quickly copy and just overwrite that real quick. So now and that's going to also be under source and EI inertial sensor, the C++ file. So just overwrite what you have there for these 36 through 39. I put that in the chat. And then the last one is main. If you scroll down to the bottom of main, which is also under source main.cpp, we have an EI inertial sensor init and an EI inertial sensor or environmental sensor init. And we're just going to get rid of both those. And now we're only using PDM, and that's really what we were doing here. If you use the, the 062S2 that this is originally built for, you don't have to make any of these changes. But since we only have the PDM, this is how we're going to get this to build. Now, once we've done this, you can go ahead and generate launches for Edge Impulse, and it's just going to make sure that we're actually going to program this correct project that we're on to our device. This only takes 10 or 15 seconds, and then we can go ahead and program our device, which I've already done for mine. So when you're done generating your launches, go ahead and you're going to do the Edge Impulse continuous motion recognition program, and plug your device in. One quick note there, I'll actually share my screen. If it'll share for me, come on, or not share my screen, start my video. So if you can see here on this device that we're using, you're going to want to connect to this, this connection here instead of the one on the end. The connection up here actually has the programmer and debugger, and the one on the left does not. So make sure you plug into the top. If you don't, it'll say, your device is not connected. So just connect to that once again, right here, and you should be good to go. So select program, and then we'll have the code example up. And you can actually go ahead and open a command prompt. And this is where that Edge Impulse CLI that we recommend that you have, or you need as a prerequisite for this, is going to come into play. So we have our device programmed and good to go. And now open a CMD, and you can run Edge Impulse daemon. So it might be wise for everyone to also run this with clean. And make sure that you're signed into your account and that the project we're working on. If you run it without clean, it'll go to your last project and connect your device to that. So ensure that you actually are, run it with clean, sign into your account, and then select the current project that you want to work on. I've already done this, so we're gonna skip that for me, but go ahead and do that to make sure you're on the correct project. Give this a second to connect to the device. Come on. So now it'll give you an option also which device you want to connect to on which COM port. So Cypress, and Cypress is a legacy Infineon company. So don't be scared if you see Cypress. That is, originally Cypress was the one who developed this board and is now acquired by Infineon. I can actually stop sharing my video just to save some resources. And so we're going to select Cypress. Oh, come on. We're going to select Cypress, and then that is actually going to connect our board to Edge Impulse's cloud structure and our project. So you can see mine is Workshop Live, you can see here. And now we are able to connect to that cloud infrastructure and be able to transmit data. So next, you're going to want to actually bring up your dashboard and make sure that you're on the correct connected project. So you can see here, I'm on, Workshop Live. That's what I just connected to. If you're on the wrong project, your device will not show up as connected. It's just connected to a different project. So next up, we're going to do some data acquisition. And I actually, at the top, and I can actually repost it, but at the top, you should see Edge Impulse data zip. Go ahead and unzip that. This demo or this workshop takes about 10 minutes of data to create a good model. And I don't want to sit here just pouring water for the next 10 minutes. So I'll show you how to collect about 10 seconds of data. But then for the rest, we're just going to import some data that I've provided. So once again, at the top of the chat, you should see Edge Impulse data.zip. Go ahead, maybe put that on your desktop or your C drive or something, and then unzip it. And then we're going to use that in the data acquisition piece. So start doing that. And then once we go into data acquisition, We can see here my connected device, PSoC workshop. So we have that already in there. And then this is where you can actually bring in, you can collect from your device, and I'll show you how to do that after we upload some data. You have training data, test data. You can explore the data, upload or export any of your data. So first, we're going to upload the data that I've supplied you. You're going to choose files, and then wherever you stored that Edge Impulse data, you can see I have here. So first, I'm going to do testing, and we're just going to select all this testing and select testing in here and uploading existing data. And then we can leave infer from file name, because I have also just to collect all this data, I exported it directly from Edge Impulse. So this is testing, and then infer from file name, and you can begin the upload. This will just take a few seconds, and then we'll have to do the same thing, but for the training data. So you can see now we've done, we have 5 different files for testing, and now we can actually choose the other file, go back into your data, training, and select. You can see how much training data we have. I believe it's about 12 minutes. And you can go ahead and open this, and then make sure for the training data that you select training, as that's going to be the category we want this to go into. We're going to leave the label infer from file name and begin upload. And this just makes it easier, so we don't have to actually go in and have you guys collect 12 minutes of data. We already have enough data to get a relatively good model going, and then I'll show you how to actually pull data from the device. And then you can actually select a label there, and we're going to have 2 labels for this classification, which is going to be pouring and noise. And then we can walk through actually building your model and seeing, how it works with validation data, test data, and everything. Let's give this a second to upload. My PC is not having a good day today. Come on. If there's any questions, I can go through those now. If anyone is running into any issues, I'd be happy to take a look at those. Come on. There we go. But yeah, so once we have this data, it'll be really easy to train our model. We're going to use a lot of the default options that Edge Impulse supplies, and it makes it really easy to go from, it took 12 minutes to collect this data, and we can go back over to training data to creating a model that functions well in a few minutes. So you can see here all that data should be, and we have it already labeled pouring noise. And to collect your own data, it's actually really easy. We have our connected device, our label name. Let's say we're doing pouring for this. Our sample length, I'm just going to do 5 seconds just to show how to do this. I would say collect maybe 5 seconds of pouring and 5 seconds of noise just to show you how to do this. And then set it to your microphone. And then your frequency is going to be 16,000 hertz. And then you can actually start sampling. And here we'll just share my video again. So you can see I actually have, oh, I don't know if you're going to be able to see that. There we go. So you can have, I have my kit propped up. Put that a little more this way. And then I'm kind of cheating. I brought a pitcher and a big bottle just to be able to do this. So you can see we're just going to start sampling and collect some data. And we have it set to 5 seconds. And also while I do this, you can see it's actually, it sent that configuration from Edge Impulse to the device, and then it's going to do that that sampling and send it right back to Edge Impulse. Makes it really easy to collect more data for this. This takes a few seconds to upload, and then we are good to go. So that was, just collect 5 seconds of pouring. So after this demo, I'd really recommend actually going and starting from scratch and collecting your own pouring and or noise. I did add some noise that was from a fan, some people talking, just to try to make sure that noise was a well-rounded training sample set. I am going to get rid of this mostly because I was talking over as I was pouring, and I don't want this to perform poorly. But that is how you collect data. If you need to collect noise, you can simply just put noise in here instead. Do your 5 seconds or up to, you know, whatever you need. Most of these I did about a minute of sampling, and then you are good to go. So next in, we have all our data. You can see we have a good train test split of 84 to 16, and then we have 7 minutes of noise and 5 minutes and 5 seconds of pouring. So we should be good to go. Next, you can go into your impulse design. And you can see here we can kind of set up our model. We can set up any processing block we want to run, and then we'll be running a Keras learning block. So first up, we have our window size, and this is how much data it's going to feed at once. And 1,000 milliseconds is perfect. And then our window size, we're actually going to make this just a little smaller. And our window size is actually how much data, it's our data shift. After 1,000 milliseconds, it'll shift the data by 300 milliseconds, and then rerun that data set. We can also, sorry, just realized I was still sharing my video. So now frequency, we're fine here. Make sure this is just set to the same frequency that you collected data with, which in this case was 16,000 kilohertz or 16K hertz, and then 0 pad. So this option, I normally get rid of it just for right now because we have enough data. But if you have a sample that is not complete, you only have half the data in that sample. So typically your last sample in your collected data, it'll pad the rest to make sure you have a full 1,000 millisecond sample with zeros. Next up, we're going to add the processing block, and we're just going to do an MFE. This is a MEL bank or a MEL filter bank energy feature, and we're just going to add that in. And the MEL bank or the MEL filter bank is good for sorting continuous frequency into bins and trying to simulate human ears perception of sound. So this humans do not hear different frequency ranges in the same amplitude. So this tries to mimic that a little bit. And then sorts the auto frequencies for you. Next up, you're adding your learning block, and you can see starred. Edge Impulse recommends this, and this is classification with Keras. So we're just going to add that in, not really much. And you can already see that, you know, we back in data acquisition, we already put there was noise and there was pouring. So it just pulled that from the data and says that we have 2 output features. So this is good just to check. And then our input features is coming from the FAE, that MEL bank or that MEL filter bank. And then we're going to save this impulse because this is going to be our whole, our pre-processing and our model. And now after that's done, we can actually go into our MFE and we can configure some things. Everything here is actually good. What we are going to do is down at the bottom, we have a noise floor, and we're actually going to shift this from 52 to 74 just to increase the, you can see how it changed the spectrogram there, just to increase what our floor is and include more of that data. And the nice thing is you can actually go and pull this slider across and see how it changes and what your spectrogram is looking like and what that MEL filter bank is really doing. After that, you can save parameters. And we're going to go ahead and generate features. And this is going to go ahead and run for a second, but it's going to generate any feature that our Edge Impulse is going to generate all the features from that MFE filter, and then include it. Sorry, my neighbor's power washing. It's a little loud. I hope no one can hear that. So it's going to generate any of your features, and you can see you also have classes here, noise and pouring, and in our data set we have 12 minutes of data. So it's actually going to go through and look for all the features in those 12 minutes of data between noise and pouring and try to get all your features together so that when we actually generate our classifier, we already have a pretty good start on the pre-processing. And then when we go for deployment later, we'll actually have the C++ files that will include this filter bank. And all we have to do is import that into our current project. And then it's relatively easy, and we don't even have to mess, you know, we don't have to try to figure out how to generate the filter bank for us. It's already done, already created. And PC's not having it. We'll give it a second. Of course, if there's any questions, please put them in now because I do have a second while this is running. And the nice thing is once this is done, you can actually see the output here. So you can see peak RAM usage, your processing time, and you can see how it's classified some of this data. So you can see we kind of, with those features, we were able to split off these groups into different different clusters. And so it makes it a lot easier when we actually go feed the model. So next, we're going to configure the neural net classifier, which is all under Impulse Design and Neural Net Classifier. Everything here is good. You can change the number of epochs, the learning rate, and the validation set is set to 20. I'm going to actually start training this so I can talk as it's going. This is all pretty standard, and if you leave this alone for this project, we're going to get a project that runs very well. You can also check 1D convolutional or 2D and switch that. You also have data augmentation, which is really nice. You can create more samples from only the samples that you've collected, so you can actually get more training data out of and without having to collect more data. You're also able to go in here and select, change any of your layering to that model. So if you're not getting good performance, you can come in here and decide, you need some more layers, maybe some more input features, your dropout rate can change. So, it's nice, it's all configurable, and it makes it really easy to just generate this model with very little know-how or knowledge. Edge Impulse pretty much takes care of that all for you. It looks like we only have 50 epochs to go. So this will actually, you can see here, we also have loss and accuracy, and you can kind of see that as we run through each epoch or each iteration of our data. And then once this is done, we'll also get a good graph of our validation set. It'll run through and tell us, what we validated in our validation set as noise or pouring, and we can make sure that we actually trained a good model. And then you can go back in and change any of your layers, or you can add data or take data out if maybe you collected it while, it wasn't good, clean data. So yeah, makes it really easy and nice. We'll give this 2 more seconds and you can actually see what I'm talking about. Come on. And you can see here, we will get a float 32 and an int 8 coming out of this output. Come on. And so you can use those. And later when we do some validation, you can see there's if there's any performance hit between going with float or just the difference between how much flash, how much RAM, how many cycles it takes to run the model, because you're typically going to run quicker with an int 8, but maybe lose some performance. So there's a nice little way to check that later down when we actually did the deployment. If it's just a few more seconds. Come on. I'm really hoping you guys are not here. It's my neighbor decided to power wash in the middle of this meeting. So I apologize if you guys can hear that. Hopefully my headphones are keeping that, canceled, but come on.
We can hear it, but it's no big deal. It humanizes the workshop a bit. And yeah, we can hear you just fine. Don't worry.
Okay, perfect. So sorry, this took a while, but we're now good. So you can see now with that 20% validation set that we are now testing our trained model with, you can see we correctly classified noise and pouring. So we got a 0% loss and 100% accuracy. And you can see we have these good clusters of what noise and what pouring are. And you can also see the inference time, the RAM usage, and the flash usage. So now we can actually go in and say, okay, well, that did good on the validation set. Let's actually check with our data. So now we can go into model testing. And I've already actually included data for you to test with, but if you want, you can also do the live classification, which is pretty much going to do a lot like the data acquisition we did before. You can collect data on the fly using the CLI daemon and be able to classify that data with now your trained model. Now the model testing. So this is already, I already collected this all for you. So you can just go ahead and classify this. And we're pretty much just making sure that the model that we've produced is actually a good performing model. We don't have any issues, in some of these I tried to split this out into pouring into different cups and then also noise of like a fan running in the background and some noise of people talking in the background, just to make sure that it classifies those correctly, and that, you know, it's not, when people talk, it's not classifying that as pouring water. We're actually getting a good classification from our data. And so this should show up in about 5 seconds. Job completed. So you can see out of all these, we're getting good clustering here, and you can see that we get 100% accuracy. It knows this is noise just based off the expected outcome and how we brought this in and labeled it already. And you can see that we have 100% accuracy across the board. So we're assuming this is a really good model. We've now tested it, and now we want to go into deployment. I'm running out of time, so I'll try to get through this quick. It took things a little longer to build. So now we're just going to use the C++ library, because we're actually going to go import this into the project that we set up. And then down here, you can actually see, you can do quantized int8 or unoptimized float32. And I'm just going to use float32, and you can actually analyze the optimizations. And this gives you a good idea on, you know, should you select int8 or float32 based on your RAM usage, flash usage, latency, and the accuracy. And in this case, it wouldn't really matter if we used int8. You can actually see Edge Impulse start this, because we get such a good performance. We get a really good accuracy, and we have a significantly low latency. So I'm going to just keep this on float32, but it shouldn't matter which one you use. And then we can go ahead and build this. And this is going to put that MFE filter, your model, any information on, you know, how fast our sampling rate for the PDM, our digital mic, and store that all into one folder. Once you have this, you can just go ahead and download this onto your desktop and then unzip it, because we will be importing this into our project. So once you do that, we can actually open Modus back up. And then wherever you have, here, I've already unzipped this just to make this easy. So you can see we have my Edge Impulse workshop, and these are all the files you need to actually run this model. It's already put there for you, and the way the code example is set up, you just need to import these in, and then it'll actually use this. So we can just copy these, and then wherever you have stored your Edge Impulse continuous motion recognition workshop. So here I have it actually under my Windows C. We saw how I did that earlier. And then we have Edge Impulse continuous motion. And then down here we have our EI model. And then we can actually get rid of everything in our current code example. And then we are going to paste in our new model and give that a second to run. So now we brought that model that we just generated with all that data into our project. So you can actually see that under here. We have all those files, and then you can just go ahead and program, and then that's about it. You now have your model that you generated with your data in your project, and then I already have this programmed. So then you can bring up your command line, and then you would want to run Edge Impulse run Impulse. And instead of sending data this time, it will actually be taking that data in, running it through your model, and then you can see, oh, did I spell something? I spelled it wrong. There we go, run Impulse. So you can see that there. So now it'll actually start feeding data. And we're going to select the current kit. And okay, so now we're recording. You can see as I'm talking, we're getting noise and not pouring. And then let me turn this back on, actually. We'll start my video back up so you can see this. So I have my pitcher here full of water, and I'm going to take this, and as I pour, you can see it now detects that I'm pouring, and we get that, you know, 0.999. So it's pretty well-performing model. And we can exit out of that. Oh, come on. Oh, that's because I'm connected to the wrong thing. There we go. Let me put Good. So yeah, this is the workshop. You started with pretty much nothing. You was able to import and showed how to import that model and or how to collect data, run through all the Edge Impulse pipeline, and then be able to generate your model and import it into the device. We can now open it up to questions, and if anyone has any issues, we can also work on those here. So yeah, feel free to ask anything you need.
Great workshop, Nick. Really enjoyed it. And it's really nice to see our partners using the Edge Impulse platform with their own tooling. So this is great to see. But yeah, please go ahead and ask questions in the chat. And if there's any questions, like for example, if you don't have the board, and you're going to follow along later on after it's been recorded. If you have Edge Impulse questions, please go ahead and ask us on our forum at forum.edgeimpulse.com. If you have any Infineon related questions, you can also email us and we can redirect you to the right platform for Infineon to help you with that as well. But for Edge Impulse specific stuff, please go ahead and post in our forum or email us at hello@edgeimpulse.com. We'll stick around here a few more minutes in case you have any questions or any comments. Please leave it in the chat or in the Q&A box. Hi, Mac. Thanks for joining, and thanks for the great commentary.
Yes, thank you for joining. And yeah, that was actually good. It would have been good to collect data during the pressure washing so that we could actually get a little bit that noise into when we train our model, so we could actually maybe filter some of that out. And get an even better performing model. Yeah, stuff like this, it's always, clean data is really a great place to start, depending on what you're trying to classify, having a good data set. And that's the first time I generated my model. I just tried doing it with silence and noise, or the noise was actually just silence. And then I tried doing pouring. And when I talked, it would classify that. So I just had to go back in and, I talked during the noise collection process and then regenerated my model, and it completely, the model then learned that was noise when I was talking and then classified that correctly. So there's a little bit of that playing around and making sure that, if there is something misclassifying, it's very easy to go in, just add maybe a minute or a couple minutes of data on something that's misclassifying, and it should retrain your model in a way that classifies it properly.
And Nick, you might have touched on this, but what can our attendees do from here? We have this base model. Is there any other applications that we could use with this sort of water detection, or is there any other sort of industrial purposes we could use to apply the same technique?
Oh, of course. I mean, it's really up to the end user and what you need. So if you're using this kit in specific, you're really limited to the PDM. But if you use the one that's fully supported by Edge Impulse, which is the 062 S2, you also get the IMU and the barometer. So you can do things, specific PDM wise. Running water is a really good one. You can do, faucet detect. Some people have problems leaving the faucet on and leaving water running. So you can actually go and have a classification detecting if your faucet is running past a certain time. If it's continuously running, then maybe send out a text message or upload somewhere on the cloud saying, hey, your water's running, and do all that modeling, running your model on a PSoC device, and then telling you that you left your water on. You could also do something with like a burst pipe, collect data and see, water's continuously pouring out of this pipe. We need to alert someone. So you don't have to continuously watch or check for these things. You can do it all through Edge Impulse's modeling, and then use PSoC to connect to Wi-Fi to send data to you saying, a burst pipe here, the machine learning that the model's classifying as a burst pipe. You can go check that. I mean, and it's really, you can also do that. There's, different use cases for each different sensor. The IMU, you can, gesture classification is a very popular one for people to start off with, where you can do different gestures and it'll actually classify what gesture you're doing. You can collect data that way too. And in that, you can, you can also do more than just the two classifications we did today of noise and something else. You can do as many classifications really as you need. So maybe water's on, or you could do like dog barking or someone's pressure washing. So you can really go anywhere from where you want. It's all about just collecting data and then using the pipeline that Edge Impulse provides to make it very simple.
Great, thank you. did you have anything else that you wanted to add in these last few minutes? I also know that you had some links in your slides. I was wondering if you might post those links into the chat so our attendees can have them, because I think what we're actually going to do is we're not going to be distributing the slides.
Okay, no worries. I did put the slides in, so if people want them, that's totally fine.
Oh, did you? I didn't see the link.
Yeah.
So...
I put it up at the top. I'm hoping everyone can see that. It's the Edge Impulse Workshop PowerPoint. I can put it in there again if that works, or I can just post links to the slides.
Could you,
Oh,
you can send the slides. Can you make sure that you send it to everyone? Maybe it was only sent to the hosts and panelists.
Here, let me, Edge Impulse Workshop. So yeah, you'll have a link to all those. You'll have, yeah, you'll be able to use all those links. It's uploading right now, and everyone should be able to have that. So yeah, so there's tons of links in there. One to set up, Edge Impulses, CLI, which we've used in this workshop, and then everything else on slide 6 is a really good place to start if you need any information on any of Modus Toolbox's information or any of Modus Toolbox tooling. And then also we do have an appendix on slide 12. So if you need any support for Bluetooth, Wi-Fi, PSoC, a getting started tutorial, we have links for all that information as well to make it really easy to do quick start.
Great, thanks. And y'all are the lucky, if people who were here that left, y'all are the lucky winners of the slide content. But yeah, that's in the chat that Nick just posted. But thanks for that. But yeah, that's great. Really good workshop. Really nice to hear, and it went so smoothly, and I love to see it. Do you have any other thing anything else that you'd like to add, or does anyone in the chat have any further questions?
I think we're good. I don't have anything to add. It doesn't look like there's anything in the chat. So thanks for coming and watching. This is Edge Impulse and Infineon. Thank you.
Thank you so much. And again, if you have any questions about today's talk, please send us an email at hello@edgeimpulse.com. Thank you for joining.